All right, well, we can get started. On Google Classroom, there is Zoom meeting notes for today, if you want to open those up. And I'll share my screen so we can go over the notes together and talk about a few other things that are assigned. All right, right at the beginning, McKenna, synthesis. What do we know about synthesis? Just some notes. Recognize a synthesis reaction? Or...
Is that the one where there's only, wait, there's only one product?
Yes.
Okay.
A decomposition, Lexi? How would you recognize a decomp?
I was on mute. There's only one reactant.
Correct. Okay, sorry, Maya, you got a harder one. How do you recognize a single replacement?
Why am I muted?
Now you're not. I don't know.
I was. Okay.
Okay.
Like when you're done, like at the end, there's only one thing that you've replaced.
Okay. So it's a reaction between a blank and a blank. What?
Don't know.
Why are you typing so slow?
I don't know. I'm waiting for Maya to finish.
Oh, electron. Element.
Okay. Reaction between an ionic compound and an element. Okay, McKenna, back to you. Double replacement. How will we recognize it?
Reaction between two elements, ionic compounds.
There you go. Okay, Lexi, combustion.
Oh, I got it. Oxygen is always one of the reactants.
Okay. And we could also put that we form carbon dioxide. Whoops. And water. Okay, we haven't mentioned it before, but there is a sixth type of reaction. It's called incomplete combustion.
What document are we on?
Huh?
What?
Oh, sorry, Maylee. Hi. We're going through the Zoom meeting notes on Google Classroom. So incomplete combustion, Maya, what do you think? Occurs when there's not enough what to burn the reactants to completion? What
Heat.
what causes things to burn besides heat? You're right, you have to have heat. Things don't burn if there's no.
What to start with?
OX. It's not
Oxygen.
oxygen. Right? So if there's not enough oxygen to burn it completely, then it's an incomplete reaction. So instead of forming carbon dioxide in water, we form carbon monoxide in water. Now, this is sometimes why your furnaces are dangerous. If you don't regulate the, I guess, the flame, or you never change your filter, you can slow down the amount of oxygen that's burning it, and you can form carbon monoxide, which is poisonous, right? Okay, questions on that stuff? Okay, moving on. All right, so what you're gonna be asked to do is you're gonna have to finish reactions. So to finish a reaction, you have to look at what the reactants, based on what reactants you're shown. And what's the things on the right side of the arrow?
Product.
Products. So I was thinking I'm going to break this down into steps, but then as I thought, well, there's only really one step. So I guess you don't really need step one. But we have to, first of all, determine the reaction type. You got to tell which one of the six it is first before you can do anything else. So this kind of goes along with what we did up here. We have to look at the reactants. And first of all, if we say there's just one single reactant, then we know it's what type. Maylee? It's a single reactant. There's only one thing on the left side.
Synthesis?
The other one.
Oh,
Start with,
fermentation or
you just start with one thing.
what?
It's got to be decomp.
I just watched my cat throw up.
Oh, that's beautiful. You can step away and go clean it up if you want.
It's okay. Let's see.
If there are two or more reactants, then it can join. McKenna, it's a what? Two or more reactants that can join together.
Double replacement.
No.
Replacement.
No.
Combustion.
No.
And synthesis.
Yeah. So that part about them being able to join is not really that easy. Sometimes I'll have to maybe tell you it's, one product. Okay, third type. If it's oxygen and a hydrocarbon, then Lexi, it's a what?
Combustion.
Combustion. Right? If it's two ionic compounds, then mainly it's going to be a what?
Double replacement.
Yep. Maya, if it's a metal or a non-metal reacting with a,
Element.
sorry, with a compound,
That's stupid.
it'll make it a single replacement reaction. And anytime you have a single replacement reaction, Maya, again, you have to check what? What was that chart that I gave you? Activity.
Polyatomic chart? What?
No, that is a chart. No, the activity series to see if the metal is more reactive or the non-metal is more reactive.
Oh.
All right, moving on. Okay, decomposition reactions. Products of the reaction will be the individual components of the reacting compounds, right? So we're just going to tear a compound apart. Sometimes we're going to form an element or a smaller compound. Now, when we break things down into elements, some elements can stand by themselves, but some elements are only found as diatomic molecules. And there are 7 diatomic molecules. Like H, if you read ahead, H we never see by itself. It's always H2, hydrogen gas, oxygen gas, chlorine gas. Right? The ones that I didn't list, let's see, chlorine gas and iodine gas. So there are 7 diatomic elements. Now, I didn't think about this, but shoot. All right, let me stop share for a minute. There, about these diatomic elements, the 7 diatomic elements, here, let me show you this. Okay, well, that's the periodic table, right? Right? So there's 7. Hydrogen's one of them. I didn't need to click on it. All right, but the other 6, they're right here, which kind of make, you know, the number 7. That would look like the number 7, right? Those are the 7 diatomic elements plus hydrogen. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Right? So you can kind of remember the 7 and what they are, because if you look at where they are in the periodic table, they kind of make the number 7. Okay? Say okay.
Okay.
Thank you. All right, let me go back to the notes. All right. Okay, and then when we do these, you know, decomposition reactions, water is pretty, you know, common. So if a substance has the ingredients, right, to form water, water will be formed. So water is going to be one of those things, unless we're breaking down water, right? If we're breaking down water, I mean, we're not going to form water, right? We'd form hydrogen. Oh, what happened? Hydrogen. And sorry. And oxygen. Whoa. All right. Okay, synthesis. So again, synthesis, product of the reaction will be always a combination of the elements or the compounds that were the reactants. So we're just going to put them all together. So the example here, hydrogen and nitrogen combine to form HN. So hydrogen and nitrogen go together. Then you have to look at the charges to get the right formula. So hydrogen has a +1 charge, nitrogen has a -3 charge. So we'd have to balance out the charges. This particular molecule, we usually kind of write it the other way, NH3. Not like that was wrong, but if it's NH3, we might not call it ammonia. We might look at that and say, hey, that's an acid, right? That would be hydronitric acid. Which really is the same thing as ammonia. Ignore. Okay. Okay, combustion reactions, product of a combustion reaction. We always get what?
Water.
Water. So if something's burning, we're using water and carbon dioxide. Sometimes, again, if it's incomplete, carbon monoxide. Okay, double replacement reactions. Product of a double replacement reaction will be similar to reactants. The blank, the second of the two ions. Is that the cation or the anion? The second one listed. So like magnesium chloride. Right. The chlorine is called the what?
Cation.
Yeah.
Anion.
Anion. Right. The second of the two ions that make up the compound will be blank. Right. Will be switched. So they're going to exchange the candy. All right. Example: aluminum chloride and sodium hydroxide react to form aluminum hydroxide and sodium chloride. So the two negative parts, the chlorine and the hydroxide, switch places. Okay, single replacement. The products of a single replacement reaction will be similar to the reactants. The metal or sometimes it's a diatomic molecule. Like it's the chlorine, hydrogen, oxygen, fluorine. We'll swap places with the metal or diatomic in the reactant. For example, calcium bromide and chlorine react to form calcium chloride and bromine. So chlorine and bromine switch places. All right. Remember to calculate the correct formula. Calcium has +2, chlorine -1. So what would be the formula?
Oh, CaCl2.
CaCl. All right, and bromine's diatomic, so its formula would be anybody? Diatomic?
I don't know.
Diatomic means 2.
BR2.
Br2. All right, so let's see. Synthesis, combustion. Okay. Let me stop share. Okay, so take yourself to Google Classroom real quick. You'll really be excited for what's there. Okay, on Google Classroom, you should notice towards, well, on my screen at least, it's towards the bottom. There are 3 educational games. Don't React Escape, React Lab. Oh, why is that on there?
Are they via Legends of Learning?
Yes.
Okay.
I guess there's just 2. I don't know why I put that one twice. So yeah, I guess there's just 2 games, but 3 different, you know. Okay, so when you win that game, just take a screenshot of your winning screen and email it to me. All right. Also, you'll notice on Google Classroom, there's a writing worksheet, writing reaction worksheet.
Is it types of reactions worksheet?
Yes, type of reaction worksheet. It's just under a Google Classroom worksheet. So I'm going to share, just so we're all looking at the same one. Okay, so type of reaction worksheet. All right, for right now, all you have to do on that worksheet is just tell me what type. All right, once we do that, then we'll go back to that same worksheet and we'll fill in the lines that come before it. Because these lines we might have to use some of these lines to balance the equation. We'll talk about balancing after this. Okay. So for right now, though, just what type of reaction it is. All right. So if we look at the first one, what do you think, Maya? It's a compound and a compound forming a compound and a compound. So there's only one choice it could be. What is it?
Synthesis?
Huh?
Synthesis?
Okay, synthesis would only have one thing on the right.
I don't know.
Sure you do. You see how bromine and this PO4 switched places? All right. So if we look at the notes, that's the one we filled out. It can't be synthesis because synthesis only has one product. Can't be decomp because that only has one reactant. Is it a reaction between an ionic compound and an element, or is it a reaction between 2 compounds? What do you think, Maya?
Compound.
It is a yeah. So all you have to do on that worksheet again is just fill out the lines there, the type of reactions. Let's see. All right. I don't think the link showed up on Google Classroom, but could you go to Khan Academy, Kahn? Do Do you ever use Khan Academy for math?
Yeah.
Okay. So you should have an account, and I put you in a chemistry classroom. You start working through the Khan Academy activities and earn points.
Bless you.
Thank you.
Oh my gosh. We made a
I don't know how to log into this.
Just
Log
go
in with Google.
I tried it, said it didn't work.
That's impossible.
If I click login with Google, it says an application is requesting permission to access your Google account.
Yes. Let,
Wow.
yours too.
okay. So as you look at Khan Academy, there's a series of videos, and then there's be a quiz after that about chemical reactions. So just kind of start working through that. I know the due date, they all say tomorrow at 11:59. I'll go back and change that. All right.
Are all of them due at a certain time?
No, I'll decide the due date. I'll put probably half of them due for next week, like by Monday. Okay, the only other thing that's assigned this week is a POGL on types of reactions. And that's listed on your Google Classroom.
I don't think I'm on the right thing.
For Khan Academy,
Yeah.
let's see if I can get a direct link here.
Do you have a class code?
I don't know, do I? It just said it would sync with. Well, I have a new student in my class, so someone got there. Students. Okay, class code, yes. Is TY, let's see. I'll share my screen. It's that one there. Got it?
Yeah.
All right. Everybody good? Okay. And then the POGL is on Google Classroom, types of reactions. And you shouldn't have too much problem with that. We've talked about most of the stuff in there. All right, so everybody good? I better let you go unless you might have another class, who knows? College prep, maybe? All right. All right, so have a good week. Reach out if you have some questions. Bye. Bye.
I
All right.